Hello everyone, my name is Chris Fitzpatrick, and welcome to my Lab 4 presentation. So, the purpose of this lab was to examine the motion of a spring mass system in which the mass swings in an arc while oscillating on a spring, and to solve for the values in the system. The fundamental physical principles in this lab were Newton's second law and the law of conservation of energy. And a summary of the lab is I created the model in GlowScript, I answered the question, is the energy principle satisfied, and compared the oscillation estimates in the x and y dimensions. So, the fundamental formulas for this lab were delta P is equal to F times delta T, F net is equal to F spring plus F grav, the magnitude of F net is equal to the K times S plus mass times gravity. Delta E is equal to 0, meaning that the change in energy is 0, because the energy principle shows that the energy is conserved. K is equal to 0.5 mv squared, which is the spring formula. And then the spring potential is equal to 0.5 ks squared. And the gravity potential energy is mass times gravity times height. In solving for this lab, the mass was 0.402 kilograms. The initial velocity was 0 meters per second, which is also shown in the form of a vector right below. The period is 1.54 seconds, which was calculated by reviewing the video frame by frame and calculating it from there. And the initial x position was negative 0.107, 0.6360. The gravitational force is equal to mass times gravity, which was in vector form 0, negative 3.940 newtons. The period is equal to 2 pi times the square root of mass over the k constant, and I rearranged that formula in order to solve for the k constant, which was 6.67 newtons per meter. The magnitude of the gravitational force is equal to the magnitude of the spring force, which I used in order to solve for the relaxed length of the spring, which was 0.109 meters. And here's the video. And then I used all that and I put it in my code. So yeah. And then here's more code. And the last few lines of code. So here are my graphs that I got from GlowScript. And the first one is the position versus time graph, and then the second one is the change in energy versus time graph. So, the what-if questions. The first what-if question was if the energy principle is satisfied, and the answer is yes, the energy principle is satisfied because delta E is equal to 0, which can be seen in the change in energy versus time graph. And for the oscillation periods, as the second question, for the x-axis, the oscillation period is 1.66 seconds, and for the y-axis, the oscillation period is 1.54 seconds, which again was done by looking at the GlowScript video frame by frame and calculating it from there. And that concludes my presentation. Thank you very much for watching, and I hope you have a wonderful evening.